a few slides to share with you to just give you a little sense about me and my background. So we'll be spending time together in this class. Um, Originally from Wisconsin, but moved to Indiana. I was pretty young. Uh, Went to IU Bloomington um, and did a degree in physics, and went to Louisiana State University to do my PhD. I was a postdoc for a while after that. My first postdoc started at the University of Missouri and then moved to University of Colorado, the Center for Astrophysics and Space Astronomy that was in clusters of galaxies, numerical cosmology. And then I came back to LSU and did a postdoc in numerical relativity, relativistic astrophysics. Joined the faculty at IU Kokomo in 2008. I'm now a full professor, and I've been associate dean in the School of Sciences for a few years now. A little bit about my research work, what I like to do, um, like numerical simulations in computational astrophysics. Uh, I find that particularly fun thing to do because there are a lot of interesting things that you can study, interesting things that happen that don't fit well into human size scales or time scales. Um, but you can visualize what would happen by applying the laws of physics as we understand them uh, to uh, dynamical systems to basically do experiments, but numerical experiments. So just a few examples of this. This beige surface is a constant density surface from a neutron star, and the neutron star has merged. Most of it has actually fallen in to a black hole, and then the white lines are showing the distribution of magnetic field lines that have an origin in the boxed region. So a fully relativistic simulation of a neutron star black hole merger sort of thing that uh, pops up every once in a while from things like LIGO. This is a simulation of the merger of two magnetized neutron stars. So you see the magnetic field distribution and um, the deposition of energy from magnetic reconnection in the orbital plane of the two neutron stars. And then this is a non-relativistic simulation. This is a merger of two white dwarfs. A less massive white dwarf is on the left. Um, Being less massive, it has actually the larger size. And if those two white dwarfs get close enough, it can start donating mass to its companion star, falls over, and shock heats and quickly goes from very, very, very cold to something like 150 million Kelvin. So if there's any hydrogen that was left over in the white dwarf, it would ignite, and all sorts of things can happen in the last few minutes of a merger of two white dwarfs like this. So those are the sorts of things that I do aside from teaching classes and doing public outreach and that sort of stuff. I do numerical simulations in computational astrophysics.